Jai Hind, Jai Bharat, and welcome to Dev Talks. This is Aadi. Jet engines and fighter aircraft. A topic that in India is not very openly spoken about because we have deficiencies. And let me say that right at the outset. A lot of hopes have been set on a jet engine deal which is coming through with the US, looking at production of fighter aircraft within India at a much faster rate. And of course, the future versions of the Tejas, the TBDEF, and of course the AMCA going forward. There's a lot which is in the pipeline. We need to understand a couple of things. Now, I asked this question to Air Marshal Bedi, who's here with us today. First of all, sir, good evening and thank you for joining me. Welcome to the show.
Good evening, Adi. Thank you very much. It's always a pleasure to be here with
So,
you.
sir, I was saying,
Thank
I
you.
asked you this question. Sir, kya baat hai, sir? We can make rocket engines. We can send something to the moon, the Mars. I believe we're also planning a solar mission now. Our rocket engines are supposed to be one of the best in the world in terms of fuel efficiency and cheapest and this and that and the best. What is the game? So why can't we make a jet engine? What's the big deal in this jet? Let's begin with that and then we'll get into the US का game and everything like that. So थोड़ी सी light सी बात कर लेते हैं पहले and then we'll get into the main subject. Thank you, sir.
Yeah, thank you, Adi. It's very stimulating, to know about this. That why, how come that we can make rocket engines? We have GSLV, we have PSLV workhorse, and we are short on jet engine, and it's been
Sure.
troubling us, like we've all seen in our LCA timelines and in the production. Now, what happens is what I see the prospects of, we will talk about it later, but engine TOT from where we started, that it is likely to happen. GE, a transfer of technology of engines or any transfer of technology. I am what comes to my mind is a famous saying. They say if you give a man fish, you feed him for a day, but if you teach him how to fish, you will feed him for life. But the caveat is that you may teach him how to fish, but the end of it, if you say that this rod, thread, and hook you will buy from me, then the teaching is kind of incomplete. It has to be in totality. So this is the analogy of TOT which has to happen. That whatever TOT happens, it must happen in totality. Otherwise, it's incomplete. But now, subsequently, when we see how are we placed, we will see both countries how they are doing. But to come to your basic question, now I will take a few minutes to explain that why is it so. Now, see. Who's making jet engines in the world? Primarily four countries. It is USA, UK, Rolls-Royce UK. I mean, USA has GE and Pratt and Whitney, Rolls-Royce in UK, Safran in France, and of course Russia, a few companies. And there is a collaboration between Safran and GE 50-50 with the CFM International, which they make generally commercial jet engines for commercial airliners. These jet engines, interestingly, I mean, how did these four countries have this technology? Jet engine came into light in World War II, early years of World War II. There is a little bit of uh, I would say discussion whether who made it first, Germans made it first or UK made it first, but the
Mhm.
Germans primarily made it first, but UK, it wasn't very fuel efficient. UK improved upon it. Probably they used it first, so sometimes they claim it, but anyway, that is not important. So after the war, UK essentially transferred technology in Europe and to US, and Russia grabbed it, or Soviet Union grabbed it from Germany. So that is how all these four countries have this technology. Okay. Now, when we come to rocket, rocket science. Now we all know that rocket science has been used as a metaphor, for
Mhm.
something which is very difficult. We say, this is almost like rocket science, or if something is not that difficult, we say, come on, yeah, this is not rocket science, correct? So it has been difficult. Rockets were not easy to make, but there are many parts to that. Now, just to give you an example, a standard jet engine that we are talking of today, of the series of Mirage 2000, or LCA, or let's say WS 10 or 15, which they are making, or every engine falls roughly into the range of 90 kilonewtons to about 180, 185 kilonewtons. Okay. And your GSLV rocket can produce 5,100 kilonewtons of thrust. Okay. So that is possible to have, but this is not possible to have. Now, why you see rocket? If you look at the rocket, it seems very simple. Its physics is very simple. There is a canister kind of thing. There is a propellant in that. You light it up, and it gives out the jet velocity, and the rocket goes up based on the third law of Newton. And we all see those Diwali rockets going up. It's as simple as that to look at. But problem comes that it is not only the propulsion, but the
Hmm.
rocket science came to being was the other parts. There are million parts in a rocket which takes a satellite up. So if there are million parts, there are million errors you can make at every stage. The rockets once went, like the failures would show, they didn't carry any black box back. If it failed, it just failed. It just went out. There wasn't any repair possible on that. So what happened? It was considered very, very tricky that before you launched it, great amount of thought or mathematics went into it to see that everything worked properly the way it must work. Okay. Then why they were required? Because they went way up. You light up a rocket today and it goes up to
Hmm.
600, 700 kilometers to launch the satellite. Okay. Where your normal engines cannot operate because there is no air there. Okay. You need rocket. A rocket, incidentally, what happens is, since there is no air, it has to carry air or oxygen, what we say,
Oxygen.
along with
Hmm.
it. So a rocket has a fuel which is a mix of fuel and oxidizer, which it carries along. 80% of the rocket weight is attributed to the fuel itself. So you will have 320 tons or 400 tons rocket going and launching a 500 kg satellite into the orbit. So that is a kind of fuel it consumes. Okay. And now to make it better, two-stage rockets, three-stage rockets came up. That when you said that, okay, one stage is burnt up, discard it, because maximum amount it was, or thrust it was spending when it is going through the atmosphere, which is dense. So once it escaped the atmosphere 80, 85 kilometers, then its velocity would increase. Starting velocity about 2.5 kilometers per second, going up to about 9 kilometers per second, to average out. Okay, but now all this we have explained. That what does the propulsion involve? Okay, but still it was considered easier to make than jet engine, because the propulsion per se was kind of straightforward. It had a lot of nuances, but it can be managed. Plus, it spent very little time burning. All this that we are talking, to go to 800 kilometers will not take more than 2 3 minutes. If it's going
Hmm.
at an average speed of 7 kilometers per second. Okay. So everything would happen quickly. And the metals or the casings or whatever it is, we were not interested in reusing it. It just fell off. We are
Reusable.
not talking of this reusable rockets, which is a different technology now, or only one part of it comes back. There also failures take place. Not every rocket which is recovered is reusable. It is checked again, but most of them do get reused. But we are talking of a general thing.
Rockets.
Now, as compared to that, what does jet engine has to do? Jet engine has to work from zero speed, standing on the runway, to supersonic speeds, and not in one go. Rocket, what happened? You lit it up. There was no control over it. Now the whole propellant has to burn till it finishes. You cannot throttle it. I mean, you could not change its thrust. You could not say now go fast, now go slow. Now do this, now do this. But whereas a jet engine has to have that control. Plus, it does not carry oxygen with it. It only carries fuel. So that is why it's called air
Air
breathing
breathing engines. Hmm.
engine. It has to take oxygen from the air. So now, before I get to jet engine per se, let's see how does an engine work on the earth, on ground. Just for the viewers to understand, take a normal piston engine. Okay, we all drive car. How does a car engine work? Standard four-stroke engine, a petrol engine. What it does is it's a cylinder, and you can visualize a piston. It is at the bottom. Now it moves up. It sucks air. That's an intake stroke it gives. It takes not air only, fuel air. So it sucks fuel air. Now it comes down. It compresses fuel air mixture. To a high value. Then it is ignited, and when it expands, it pushes the cylinder upward, giving it
Back
a
up
power
again.
stroke. Yeah, power stroke. That is from where the power is driven. And now it comes back again, expelling all those gases. So there is an induction stroke, there is a compression stroke, there is a power stroke, and there is an exhaust stroke. So what we are doing, there is one power stroke out of the four strokes, and four things are happening turn by turn. That is, there is induction, there is compression, there is combustion, and there is power or exhaust. Okay. If all these four things were to happen simultaneously, that means that all the time there is induction, at all the time there is compression, at all the time there is combustion taking place, at all the times there is exhaust velocity available, you will have a jet engine. That is what precisely jet engine does. And now, how does a jet engine work? If I can, if I request you to put up that picture, I will briefly explain that what are the indications. Now, you look at this. Okay, this is a very, very simple diagram of a jet engine. Now, in the beginning, if you see where intake is written, cold section, the air is drawn from the atmosphere. The compressor rotates. Initially, on the ground, we rotate it by electrical pulse or some external source. When it starts rotating, it starts sucking air. It's made like that. Now, I'm not going into the aerodynamics of it. It suffices to say that it takes in air. Suction power is so strong that some of the airline engines, if you Google, they have sucked a man inside. A guy who
Yes,
was
sir.
not careful and came in front of the running engine was sucked in. Okay. And there have been
Corsair
many
on a,
cases.
yeah,
Yeah.
yeah.
And
On a American carrier, right? So that incident that happened.
and even on ground, even on what do you call on airports. Okay, the people's caps have gone in. The people who are not careful. So there is a strict discipline which is followed. But this is to say, this is the power of suction which gets in. Now, with this intake, this compressor, what does it do? It keeps compressing the air, increasing the pressure and temperature where it is room compression. You have low pressure compressor moving on to high pressure compressor. These compressors, how they rotate, the low pressure rotates at about 10,000 rpm roughly. Okay, and as it goes to high pressure stage, it has to rotate faster because it's working against nature. Now you see, there is already air at positive pressure, and it has to pressure it, increase the pressure even more. So, what happens is the pressure ratio or compression ratio, if you have to achieve 1 is to 25 or 40, then it has to work against hell of a lot of force. So, the
Force.
RPM goes to about 16,000 also. 16,000 RPM is not about 250 RPMs per second. Okay. If 16,000 RPM per minute, rotations per minute, so it is 250 rotations per second almost. Okay. Now, this is
Exactly.
how the engine is rotating. Okay. And what happens now? You see, if the air enters, which you see the blue lines or blue intake with air which is shown, you see it going straight. But compressor, when it is rotating, it will provide a swirl to it, right? So after each stage there is a stator, which has to straighten it, then again swirls and again straighten it, then again swirls, again straighten it. So this process continues through and through. Another thing which happens is that what are you converting pressure energy from? It is from kinetic energy, from velocity.
Kinetic. Hmm.
And if after some time the or velocity of the air dies down or becomes less, then what are you going to compress? So it not only has to increase pressure, it has to increase velocity of the residual air also. So you will find that cross section keeps becoming narrow. So as the velocity reduces, it increases its velocity so that it can be further compressed. Okay.
Okay.
So this is where it continues. Now, this is why it's called cold section, because while the temperature rises of the compressed air, but does not rise to that an extent. Now comes the combustion, as you see. Combustion is a cutaway is shown, but it is generally annular, means it's going around the whole engine. That combustion is taking place all around it. Now, for this combustion to happen, you have to reduce the air velocity to subsonic speeds. And to reduce it to subsonic speed, you have diffusers, etc., various arrangements made there. And now fuel air mixture, air is already there, fuel is injected in vaporized state, but because you see in so much of space, it has to burn completely, vaporized state. And when this mixture burns, the temperature rises to the range of 2000 degrees Celsius. Okay.
Nice.
Almost. It will vary from, I'm giving generic figures. I mean, you take engine to engine, it will vary. Okay. But let's say 2000 degrees Celsius roughly. This is the temperature now which impacts the turbine. Where you see turbine? Now this impacts the turbine and rotates turbine. The sole purpose of turbine is to rotate the compressor, which in turn rotates the compressor. Okay. So it's a self-sustaining kind of cycle which it develops. After the power which is left from rotating the compressor, other powers are driven. So engine is heart of the aircraft. Not only it is providing you thrust, it's also powering all your other systems. That is your avionics, your hydraulics, your this, your that. Everything drives power from these shafts, which are connected to it. Okay. And this very high temperature, when hits the turbine and it rotates, that is where the problem comes. That now turbine also are same spool, high pressure turbine to start with, which rotates at about 16,000 rpm, and LP turbine that goes to low pressure turbine goes to about 10,000 rpm. Okay. Now, in all this, you can imagine now that something which is rotating so fast, you did not have this arrangement in a rocket engine. Rocket was stationary in the sense the propulsive section was stationary. It just burned the fuel. I mean, it was solid or liquid. It had no rotating parts, right? Here, there are parts which are continuously rotating. You can imagine the kind of centrifugal force they might be
Mhm.
operating
Mhm.
at, or generating. So this material has to withstand all those forces, temperature of 2000 degrees centigrade and those centrifugal forces. Then the arrangement between them are, very, very small in millimeters. The difference, the difference between blades or the blade tip to the casing, etc., very, very finite. Okay. So if rocket making is a rocket science, then this engine is an art. It's a science appears simple, but it is a form of art. Okay. To get all these things together, now comes that this, while rocket operated for a few minutes, this engine has to operate for hours together at a time,
Switch on,
because you
switch
have
off.
4 hours flight, 5 hours flight, and overall it has to operate for years.
Hmm.
You have 20 years, 30 years, it's life of the engine. So the material has to withstand all these forces. That is where the problem comes. Now you say turbine, when we come to metallurgy, that we do not have, or the countries which cannot make engines have not advanced in metallurgy so much that they can have materials which can withstand all these forces. This is a very generic explanation, for this channel. Anyone has a specific question, we can definitely take it in question answer sessions. Okay. But now turbine blade, you cannot have a material which can actually withstand so high a temperature. Even titanium melts at 1700 degrees. Okay. You need very fine alloys, carbon, carbon, or this or that, etc. when you get into material science. But the technology which becomes important is the cooling technology. Incidentally, the air which comes, from the compression, which I said it's being heated up, is also used for cooling around the combustion chamber. Now, it will surprise you that the air which is being used for cooling is itself at 800 degrees Celsius. That is the air which is being used to cool the engine. So if something with that 800 degrees Celsius is being used to cool something, you can imagine what kind of temperatures are existing in those sections. Okay. And it's not that in rockets those temperatures do not come up, but like we said, there the exposure to those temperatures is for very small duration. and you are not interested in recovering those parts, even at the end of it, when they are gone. But here I have to reuse it, not once, I mean for number of times again. So this material not only has to withstand it, it has to live it. Coupled with that comes your digital control. Nowadays, we are not going to make primitive engines. We are making, full authority digital engine. Okay, FADEC, what we call. Okay, digital engine control. What does it do? If you remember, when you bought your Chetak Bajaj scooter or earlier Ambassador car, you had a running in period. You remember that? They said for first year, for so many kilometers, don't run it at
1,000
for more than
kilometers,
40
don't cross
kilometers.
60.
60. Those kind of instructions used to come. Now your modern cars don't have that. You get it out of the showroom and zook, it tells you, 200 kilometers in 10 seconds, right? So similarly, you have reached that stage in engines. Earlier when you had to nurse them, when they were not operating, there were so many restrictions that you will not move throttle faster than this rate. You will hold at this RPM for so
You'll not slam
second
it, yeah.
before you move
Hmm.
it. You will not slam it, etc., etc. Now there are no restrictions like that. You from full engine power you can come back to idle. From idle you can go back to full. So there is a digital control available, which has to now manage all this, complicated parts which are there in the engine. And when we come to cooling technology, turbine blades are not plain blades. Turbine blades now, like I said, they have to be cooled. And it's not that you pump in air on top of that. Air there, as it is taking, of that kind of temperature, they have holes in them. I have seen a turbine blade in GTRE myself. Okay, they have very fine holes in it, that through which air passes, circulates through the turbine blade and cools the turbine blade. If you look at the turbine blade and I tell you there are holes in it, I mean, you can't even imagine. No, that is the technology, which is required. That is the machining part of it. How to make that art form. Everybody may have raw material available, but to turn it into that kind of blade or that kind of form or that kind of shape, or at each place it is very, very different. That is what is the problem, machining part of it and things like that. That is how it greatly differs from rocket. So while we will have rocket technology, going all the way up to geostationary orbit, it is difficult to make jet engine. That is why where we are. Hope that explains that why we can have rocket
Absolutely.
engine and
It
not jet engine.
reminds me of that story how the Russians figured out how to make the metallurgy, because
Yeah,
the after the Second World War, the British decided to gift what I think 5 or 10 of these you know Goblin engines to the Russians. And okay, and what happened was that the Russians said, "Oh, we wanted to see how this is made," and Stalin at that time had said, "Only a fool will share his secrets with us."
yeah, yeah.
So the Russians were sent
Probably.
there, and
Yeah.
all the Russians were wearing these nice deep rubber shoes. So where the metal was being cut, they went there and they embedded all these metal filings into their shoes.
Sure.
When they came out, they took those shoes and gave it to their metallurgy guys, and they figured out what was the composition, and that's how they built it up.
Built it up.
So
Yeah,
it was,
that's interesting. Yeah, and they had, in any case, like we said, that German technology
yeah,
available to them.
they did. But those, the Numansky engines the Germans were using,
Yeah,
they
yeah.
used to burn out after every about 11 or 12 hours of flight. So they had to be changed in that the I mean, World War II jet fighter, the Me I mean, the German
That
jet fighters,
German
Me
jet
262,
fighters. Yeah,
Messerschmitt
Me-2.
262.
Yeah,
Yeah.
yeah,
So they had problems with that, and the Neumann engines were not really uh, responsive in that particular way. So then they figured out, yeah, kuch to karna padega. And
yeah.
funnily speaking, 6 years down the line, the same the engines that they stole from the Britishers were fighting them in Korea
In
using
Korea. Yeah,
MiG-15s.
yeah,
So
absolutely.
amazing,
Yeah,
amazing things, sir. So let's get to this one now. Of course, there's been talks about this deal for a long time. This is not something that has been brought out now. 2010 also there were talks of this. Nothing materialized. Thing didn't move forward. Right now, things seem to be very, very at a point where stuff will happen. What is your perception, sir, I mean, and guys, let me just say this: this is a perception right now. It's not what is going to happen. These are open source intelligence. So
See, yeah, of course. No, no. What happens is, but what it may be worthwhile, Adi, to just see what does it take to evolve in Indian industry to begin with,
sure.
And China is a good example. Next door, it did not have that luxury of getting German technology or something, etc. So if you just bear with me, I will tell you, before we come to Indian thing, that how did it involve? I mean, how did China evolve into this, and that will give a perspective that what does it take to do it. Okay, and does it really have capability, and like we said, if we get it tomorrow, then how do we stand? Okay, if you look at China, they started their licensed production way back in 1970. Okay,
70.
and in 70 they were doing licensed production of something very small engines, etc. Now, 1976, what happened? The Rolls Royce actually gave them technology of their SPE Mark 202 turbofan engine. Okay, they gave the technology. They said that okay, you can make engines, and that was the basis of WS9 engine. WS in Chinese is, I believe, Wo Shang, meaning turbofan. Okay, and they just give it numbers. So now it was estimated, okay, that they will be able to make it in about 10 years. When did WS9 come out? It came out in 2007.
7.
So it took 30 years to develop on an allowed technology, not reverse engineered or not stolen, allowed technology. So that's what it takes to work on a technology to imbibe it. But that was 76. We are in a different era. So if at that time took 30 years, not necessary that it will take 30 years now. But this is just to draw home the point. Now, what happened is West was supporting it. China, they were supporting it with tools, etc. Machining. Generally, it was a kind of going on.
They're given a lot of tech also, sir.
Lot of tech also. But then what happened in 89? Tiananmen Square happened. Okay, that is where everything suddenly came to a little stop. Okay, and that could be another reason why that 30 years gap. Because things did not flow in a manner they would have flown. Okay, but along with that, another thing happened. 1990, what happened? Russia, I mean USSR broke up. When USSR broke up, it's all the engine technology which was concentrated in one place now got kind of frittered away.
Split
Okay,
up.
and now they also needed someone to help. So it is immediately after that when Beijing and Moscow signed their military technical corporation agreement, and Russia started helping China in the domestic development of Su-27. Okay, they said, okay, you can indigenously make it. And that is when China started reverse engineering Su-27 engine, which came to be known as WS-10 engine. Okay,
10.
and they're still flying with WS-10 engine. Now, what the fact is that while they are projecting it or exporting it to the world, WS-10 as entirely homemade or indigenous engine, the fact is not that. It is still manufactured with imported machines. Its machining is done with the imported machines. It's not completely indigenous, but at a fairly advanced stage. It's WS15 engine, which they are now developing. It started in about 1990s. Okay, they started working on this kind of thrust engine. WS10 is about 135 kilonewtons, and WS15 will be about 182 kilonewtons, at par with F135 engine, which is F22 Raptor engine.
Raptor engine.
Okay, so that will be approximately the capability. It recently flew in 2022 on a J20 aircraft. So it's still kind of tested, experimental. Series production is not
No.
started.
Yes, sir.
So
Yes,
the
sir.
biggest challenge is machine tooling. They still rely on machines from German, Japan, Italy, or even Korean. 40% of its aircraft are still flying on Russian engines.
Engines.
On that.
RD95s.
So yeah, so they are doing that now. On Russia, what was happening? Russia was progressing, again, like you said, it was going hunky dory. West was supporting it. I mean, some technology, it will come. It was making progress when 2014 Crimea happened, you know. And then again, a lot of sanctions came. They affected us also, as 400 deal came into a little
Yeah.
jeopardy post that. Okay. So, again, a little halt came into this sort of scenario. India, on the other side, we started with GTRC, Gas Turbine Research Center, way back in 1959 at Kanpur. Okay, India's story is relatively much shorter. So 61, it became GTRE and moved to Bangalore. And, they had some experience, if you remember, Orpheus engine, 703 on Marut. They initially Rolls-Royce was to give Orpheus 12, but it did not give it, gave Orpheus 703. Then a GTRE worked on that, to enhance its thrust. But that was one reason why Marut, did not go as
Yeah.
long as it would have, because its engine became an issue. Okay. Now, 86 GTRE was given the contract or the order, I would say, to develop LCA engine. And this current GTX 37 BS, they said, Kaveri, that we will make it for LCA. 89, the full kind of production started. They had made something till 2004. They made it little engine. But when they took it to Russia, we did not have testing facilities here. We still do not have many. Okay. When we took it to Russia, it failed, okay, in 2004. And then while they were still figuring out, LCA program was getting far too delayed. Everybody was talking about it, that what happened, what happened. That is where decision was taken that, okay, we will get F404 engine into LCA Mark 1, which is flying now, okay. And 2008, this Kaveri got delinked from LCA, okay. And that is when it went in cold burn. Now, again, we wanted to revive it. 2016, I think we started talking to Safran that, if they can help us revive this engine. There was a little bit of disagreement. I think Safran said that, we will need to change the core altogether. GTRE didn't want to change it. They said we need to do. So that kind of negotiations are on. Now, they want to develop, everybody, Safran, RR, even GE, other people are all they want to contribute towards MCA story that, okay, we will help you make an engine for MCA. Okay. Now, situation what you say today is that when you look at Soviet Union, while it's, I mean, it still was not, I mean, Russia, the kind of condition it is in, or post 2014, while it lost a lot of money, or it may have resource limitation, but its expertise is still there, right? The technology is there. So they have technology, they have expertise, but they have lack of cash. And look at China, it's exactly the opposite. They have a lot of cash and lack of expertise. So this is a jigsaw puzzle which may exactly fit into each other. On one
Absolutely.
side, enrich, enough technology, less resources, less technology, enough resources. Okay.
So,
So if they happen to plug in, then there could be surprise for anybody. But how much it will happen, like we said, time will tell.
so
For India's story now, this 414 thing, which is being, like you said, it's a speculation. A lot of things are being said. We will just have to watch that what comes actually. And the point would be that the technology transfer which takes place in metallurgy, in machining, in getting those machines in which you can machine those blades, and are we going to get technology just to make F414 in India, or are we going to get technology to make engines in India? That is the question. And people have to keep it in mind. I would like to say that all of us, who are sometimes impatient or skeptic, that it takes time to imbibe a technology. Even when you tell someone that, okay, here is the technology, it will take time to integrate it. So it is not that tomorrow Prime Minister comes home and within a week people are looking at that as if he should have got an engine along, or
yeah.
GTRE starts making it within 6 months or within a year. It will take time. So it is not that nothing is happening. So we all have to understand that it will take time for this to come. But I think situation will become clear uh,
in
and
the next
see
1 or 2 days.
gets in the
And
next 1 or 2 days. That's what exactly comes. Yeah.
we'll take up that issue as we discuss it, and I'd like to announce it that we will discuss this next week. We'll try and see what the actual deal that comes out, and we'll figure out how it's going to impact the Indian aviation industry, especially with regards to fighters. So we'll take that up next week. But right now, sir, this particular deal was brought out in 2009. The Americans got, I think they got spooked, and they walked back because of their, they decided to add in another link of export controls. I think 2009 this deal was being spoken about. 2010 they put in an export control, so everything went off right there. uh, the geopolitical factor, everybody knows that they want to strengthen India and stuff like that, but the larger part of it, what a lot of statements is talking about, for example, the Indus X, is to make India a defense manufacturing hub, right? So let's not get into the larger aspect of defense, but keep it to aviation, specifically to these engines. Now, when you're talking about, and just an opinion, so when you're talking about a 414, or when you're talking about a GE manufacturing plant, let's say it becomes 418 or 424, uh, obviously that technology will come in for production, because if they want us to become that hub, and if India is going towards that side, then of course the development of that engine will also happen. uh, Obviously not within India, it'll happen somewhere else, but the transfer will continue happening. Is that so, sir?
I guess so. You see, what happens is mostly when these models change, while they, for ease, they refer to, it's easier to understand that it's a modification on this engine, like even when you say WS9, 10, 15, like that. It is probably not necessary that it is the blade is made stronger or it's larger or it is this, etc. It may be
Yeah,
totally different technology altogether, right? So even in this particular, if they make India as a hub and they find it lucrative, and they find ultimately all these companies are business companies, right? They are they need money, they need profit, okay? If they find that it does not hamper their national interests, keep their control, and it's easier to manufacture the engines in India, and there is a better market available close by, then I think they should go for it, okay? And we in India also will have to develop our overall base. Adi. What happens is, it is not enough when you say engines. I mean, engine is not produced in isolation. There are so many things involved when we talk of machining, and government like Soviet Union, why they are in that condition, because it was never a jet engine making was never a profit making venture in Soviet Union. It That government subsidized a hell of a lot of money for that, and now when
because
that
it was
went
only
missing,
domestic. Hmm.
it was domestic. So they landed up in that situation. Now, do we really want to be in that kind of situation? So what happens is, you need to have a very firm base. Your big industrial houses need to play ball, that somehow they get involved and take on this industrial upliftment of India. Now, it is sad, I would say, or I mean, I have not done great research into it, but generally what I read, that we are not even making enough car engines here. That Fiat engines are used in all your high end cars. Now, if a company like Tata's or Mahindra, which are selling maximum four wheelers, do not find it lucrative to make their car engines in India, then it's a long story to tell. So what happens is, the overall industrial base, I mean, tomorrow then they have to get interested. They don't look at that. Okay, how many aircraft does Indian Air Force need? 83 Mark 2 LCAs. How many? I mean, another 100 LCAs.
Let's say
Blah blah
400
blah.
aircraft, 500 aircraft also. It doesn't make
So am I going to put this engine manufacturing plant or something, or should I invest in this kind of industry? No, that will be short-sightedness. Okay, what happens is, even America, when GE or Pratt and Whitney did not start manufacturing only for American engines, or UK, Rolls-Royce, for God's sake, does not make for UK. There are three squadron, six squadrons of Typhoon and Tornadoes. Okay, and there are, I mean, other aircraft, but I'm saying the fighter engines. Okay, now what happens is, where we say that, okay, can where can India overtake China in case this technology comes to us? Okay,
Yes.
it may not be in sheer numbers. It is not that I will start making engines before China, or I will make more numbers, or my rate of manufacturing will go beyond that, etc. Let's accept it that they have been at it. They are in an advanced stage, and we are not so advanced. But if this technology comes, critical technology comes, the biggest advantage we have is in export market. I think a lot of nations would like to buy. Let's say if there was an engine on sale in China and India at the same time, similar capacity, I have a feeling, in my opinion, that most of the countries may like to buy it from India rather than from China.
So
So that is where the winning the race over China becomes important, and it's a relay. You sell more, you gain more, you make more, and the story continues. But a lot of hard work is required. China in that way is ahead because they have their flying test aircraft. Like any jet engine you make, you would ask, how do you test it? You are not going to put it in a first fighter aircraft and launch it.
send it up.
All these jet engines are tested in transport aircraft, like il-76. China does it on yj-20. Russia, we have to take it to Russia. Now one of the engines, il-76 has 4 engines. So in one of the nacelle, you fit in this engine and you fly it and see how it behaves. We need to develop this capacity. GTRE is, requesting the government to do that. We need a lot of more test beds. It's not that for small modification you make and you now run to Russia again to test that part. Now small modification has to be done. You come back, do the modification, and again run back there to test. So all those facilities have to come up here, which to begin with appear a dead investment. That you are just pumping in money, the product will come
Later.
later. But now what will change with this deal is that once this technology is assured and it is at state level, I mean, it is a president promising a prime minister. It's not one business house to another. It has got a lot of sanctity, I would say. So if this technology comes in, then chances of this investment fructifying into a real thing increases, are much more. So then people probably can have confidence that no, machining is coming. Now they're not sure. They anybody who has to invest is not sure that GTR is taken so long. And incidentally, we are about 10 kilonewtons short. Your Kaveri engine is reached about 80 kilonewtons, and we want to make about
90.
90, 95 or something. This 414 will be about 98 kilonewtons. 404 was about 90 kilonewtons. But that much gap is very difficult to cover. It is almost like running 100 meters in, if the record is 9.9 seconds, you to make it 9.89 seconds is not just another 0.01 second.
दम
It
निकल
is
जाता है.
it's a yeah it's so you are reaching that stage. With each increment, test points increase, everything increases. So everything, all industrial hub or industrial base has to come up along with that. I think then we will be in good state.
Damn good, sir. Sir, let's do one thing. Let's get into the questions. A lot of the questions I want to ask, a lot of the viewers are also asking. We've got close to 200 people watching us.
Oh,
Uh,
thank you.
let's get into that and see what the viewers also have to say. Guys, before I do, like the video, subscribe. You know the drill. Very very simple. Spread the word. Very very critical that we spread the word and tell people that there are these sane discussions which happen about realistic issues in the country. And we don't want to speculate as per se, but we've, I think, done enough speculation as to if this happens, that happens at the moment. I think that is more than enough. We will talk about the specifics of it once we get to know, as I said. So and you can, guys, by the way, before I get into the questions, you can help out the dev talks efforts by contributing towards this effort by scanning the QR code right up here, or becoming a member by clicking the join button down there, or sending us a super sticker or super chat right from your chat box. So let's get into some questions. Loads and loads of questions. Uh, See, this is what I was saying. So a lot of people think that the G414 deal was done in 2010, as he's saying. What is new now? It was done and it was withdrawn after that from the state. So Any further comments? Or you were in the forces, you probably know a little more than me.
No,
But
no, not really. You see, what happens is there would have been many issues like, working conditions may not have been agreed. The government to government commitment. Like I know for sure, making of Rafale initially in India and then they withdrew. Before, when we were talking of 126, Rafale won the contract incidentally, right? Against Typhoon, against our
that was in
MMRCA project.
2012
Okay.
or something, right?
2012, 2011, 12, yeah, something like that. Okay. But then it didn't happen because they, now one, we may ask that, there's the contract, it was a winner. Then why didn't it happen? Okay. Ultimately, I mean, Prime Minister had to go and do a kind of a government to government deal.
G2G
Okay.
contract.
G2G contract. Yeah. Now, what happens is there were, I believe, issues. The way Dasu Aviation wanted it to be manufactured in HAL or their conditions, working conditions, etc., they did not match and it did not agree to the conditions that that they are ready to make it here. There were some issues. Okay. Now, similarly, this deal did not go through. Maybe it was not. I am not really familiar with the exacts of it. I mean, we all know what. Well, I was relatively very junior officer than Adi. I mean, probably won't have insight into great details. But what happens is, as a general knowledge, some issues, I believe, technical administrative issues, which on the working condition, and they said that no, it will not work out looking at your probably infrastructure or the way it was proposed to be done. Now we are long way from there. I mean, 15
There were
years,
export
13
controls
years.
also at that time, sir. So there were some export controls.
Yeah,
Ye wo customs and
controls a lot of issues. I mean, but now I think we should be happy it is coming through, and hopefully it goes through this time, which it should.
yes, it should, sir. Pradeep Saab, thank you so much for your contribution. He says he asks, is crystal engine blade technology being shared? I think this is one of the biggest questions.
Yeah, no idea. You see, what happens is, as of that list, like we said very clearly, exact things will come out once the deal is done. But in most of the things that I have read, they are mostly talking of machining, this, that, etc. Right? Crystal blade technology is also being developed in India. Our DMRL is doing a great job. Let me tell you that sooner or later, okay, we will get to metallurgy. In my opinion, I interacted with some other project. I have visited DMRL, I've seen GTRE, I've interacted with scientists. I am fairly confident that from metallurgy point of view, we'll get around. Okay, it is machining part of it. How to convert that into that blade is going to be the biggest problem. Even now, that 80 kilonewtons, the engine which we have made, if you go and see, its turbine blade, it is being machined, let's say here, but the machine is not made in India. It comes from abroad. It's a German machine. So that is the sort of thing, and a lot of that is why rhetoric is on machining, tooling. If you read the initial reports, the metallurgy technology may come single. This crystal engine blade is very important. It changes the scenario, and if GE is confident that things are moving, they will move cautiously, I suppose. But I won't be surprised if ultimately, when they know that we are almost there, we are close to it, this technology sharing may speed up the process. When they will also make their calculation that, okay, they are likely to get it in let's say 2 years in any case, so might as
They
well
do have control, yeah.
they share it and make some benefit out of it. Okay.
It's
But
also leverage,
major
na, sir.
problem
Yeah,
is
we
going to
gave
be
it to
there.
you, yeah. What are you doing,
Yeah, probably. I mean, there are those give and takes
geopolitical factors.
available.
Right.
Geopolitics plays, but metallurgy is an issue. It was a big issue, but we are getting around it. Slowly, slowly. But it is that, like I said, I will keep repeating, the machining part is the major issue.
Most critical. Sir, US arms are notoriously hyper expensive, unaffordable to most nations, and increasing also to the US itself. Uh, can we envision US leveraging India's scale to reduce R&D and manufacturing costs and boost arms sales? Interesting question.
Now, 1 second. Let me just see. Yeah, US technology is expensive, hyper expensive, especially when they will export. It'll be further expensive, right? Okay, now to fund India's R&D, is that what is leveraging India's scale to
It,
reduce R&D manufacturing cost and boost arms sale in India? That's what exactly.
no, sir. Actually, I think he's hinting, and this is again a debate which is on that India, as I asked you also, India may become a defense manufacturing hub. And you also noted the factor that, if in case India does become that, it is an opportunity for India to export. Now, F-16s are using this, F-18s are using this engine. But this entire region
No,
is
no.
bulked up with.
So, yeah, so I am confused because he said to reduce R&D. He essentially meant to reduce R&D cost
R&D and
or
manufacturing, R&D
cost.
manufacturing
Okay,
cost.
it's a single R&D manufacturing and cost. Okay, cost is for both. Agreed. Okay, sorry, I was getting confused there. Okay, yes, definitely. You see, what happens is R&D cost initially is high. In any kind of project, but I think we have fairly gone past that stage. Okay, but now when they start, what is R&D? You want to practice something, you want to develop something. Okay, so we provide you tools. You have tomorrow, you want to write a program, new program, you are doing a R&D, some kind of project, software project, let's say. Okay, so earlier, if you didn't have a good computer at home, or even in your city available, or close by, or let's say for everything new I have to rush to Bangalore now to try out my program and come back. Okay, so it is costing a lot to me, that R&D. While it is overall gambit of R&D, but what it involves is very different. But now, if you provide me all those facilities here, okay, you say, okay, here are the high-end computers, here are the programs, here are the guides available, there is a university which where there is expertise available. So de facto, while effort may remain same, the R&D cost will come down because now I don't have to rush everywhere. I have the tools available. I think of a concept I want to improve in something new, then I have everything readily available, which probably they're coming here will give a big boost, no doubt about it. Once you have the very presence of engineers, Adi, makes a lot of difference. We had eye opening. We flew I flew MiG-21 before Mirage 2000. Okay, MiG-21. Now, when something went wrong or something, it was a Herculean task to set it right. You took out an engine. It took you 7 days to put it back and things like that. Okay, and you talked to people. You did that from what should I say, internal knowledge. Things happened. Now come to Mirage 2000. Okay, we got posted to Gwalior. Now something you won't understand. You say, why is this particular thing happening? There was a French guy available there, 2 3 team French resident team. Okay, so what will he do? He'll say, okay, no problem. He will send a fax. Those days, I'm talking of 97, 98. Okay, and he will say, okay, we send fax. He will send a fax, and the reply would come, and within no time we have set things right. Okay, so the very presence of sound mind or knowledgeable people around you will make a difference. Now we say that maintenance on you were to say that technicians on Mirage 2000 were much more qualified or much more knowledgeable because they could handle a snag much earlier than a MiG-21, may not be absolutely true, but the wherewithal available, tools available, the technology available, the guidance available was at your doorstep, which drastically, helped in solving that problem. R&D is definitely of that, and we already discussed that. I touched that on arms sales. That if these companies find that making it is cheaper in India, or you can make more bulk here with the same price, and it's easier to export from there, then it will definitely boost arms sale, even for them and for even the Indian companies who are involved.
That is, I mean, see, that's the whole thing. I think most of us have a lot of, I won't say concern, but I'd say more of an interest with regards to how things will develop in the future. I think that's the most
It will
important thing.
develop good. What happens is, even now we are exporting some machines or LC or something. There is a great value in a stamp, brand name. You get my point? So what happens
That's
is
true.
when tomorrow this technology comes and these people are there, the guy who's buying, he knows that they are in collaboration, or it is being supervised by somebody who knows how it is to be done, or there is a quality control, which is
Sure.
there in this particular thing. So I think it will make things much better.
So, sir, even if we get the TOT, how many years will India take to make a fully indigenous aircraft engines? Your thoughts?
Yeah, my thoughts. Even if we get a full TOT, like I told, the conservative estimate, I would put. I mean, I hope people don't get put off. Or I am not exactly a tech, what you call scientist or engineer, but having known the system and ecosystem, I think if we are able to produce an engine in India, all inclusive, within a time period of 3 to 5 years, it should be a very good progress. Because just imagine, when the contract is signed, or when the deal is done, that okay, this will happen, it will take you an year or two just to set up facilities, to those manufacturing places, that where is it going to be made. Okay, you can't just take out LCA module from there and start making 414 module there. Okay, the special facilities will have to be created. Those guys will come here, supervise it, and technology transfer or teaching someone how to make
You have to
it
send a team there,
will
sit
take
down,
time.
work.
Sit down, work, etc., and start working on it. So I think that much time frame is reasonable, and we should be very happy in case that happens.
So,
I mean,
mm,
that's my view, uh, precisely.
would it not be good to start with scratch engine for a 5.56 generation aircraft, Amcar 2? My God, you named it also. uh, with
With Rolls
Rolls
Royce.
Royce, or to go with GE, Americans won't give us cutting edge technologies.
See, this is a debate now. Rolls Royce, incidentally, there was we have Jaguars, which are flying Rolls Royce engine, Ado. Okay, when we wanted to upgrade Jaguars, the which engine company got the contract of engines? Pratt and Whitney. Okay, now it was very sad, and this was exactly the time when I was here at Ashfield, London, and when I would meet Rolls Royce people, I would generally lament about it, that by now a lot of things would have happened if you had held India's hand. I don't know what went wrong. They had their own
Even
reason.
with Goyer, they've done the same thing.
Yeah. Okay. So now what happens is, now how much hand holding will they do is anybody's guess.
Yeah,
But
yeah.
start from scratch. Now you see what happens is it depends. Now you want to grow. I mean, otherwise you will keep catching up only. If you can't, the world is moving ahead. There is no doubt about it. But what happens is, when you start to train, from what level do you start realizing things? I think it will be same story. LCA also, LCA started with a replacement to MiG-21. Okay, that was the ambition. Then, like, things kept changing. Some QRs got modified, or some concessions kept coming, etc., etc. A lot of things happened. So then it was decided that okay, let's cap it. It was required to be capped at a place, that no point now making a super aircraft, like Mirage 2000. It may be, we can accept slightly sub performance from that, as long as it is good enough. Okay, making an engine straight away, start from that, from a scratch. Tomorrow, when you have the technology, you have developed base. I mean, today we are not in a position to talk about it. I think after 2 years or 3 years, probably we could do that we say
Mhm.
that okay, why continue making now for. And you remember, I exactly said that this TOT, will it allow you to make only 414s here in India, or will it allow you to make jet
The
engines in
next,
India?
the next
The next,
gen.
I mean, depending on my requirement. I tomorrow, let's say, I may not have all sixth generation aircraft. So tomorrow I say that okay, I want to make a jet engine for this class, I should be able to make. I want to make it for that class, I should be able to make. So
So,
telling someone how to make a thing, is very, you teach someone, there is a chair model, you teach him only to make that type of chair, or you teach him how to make furniture, so that he tomorrow can, as long as he knows how to use those carpentry tools, he should be able to make a chair, a table, a two-seater, a four-seater, a three-seater, things like
Mm.
that. That is what I'm trying to say. So if we reach that stage, then by all means this question would be valid, that that okay, why are we continuing in the same, let's start from scratch. And start from scratch means what? That don't modify it. What I mean to say is that you have tomorrow Kaveri engine, and I want more thrust, sixth generation. So like this gentleman, I can say that why are you continuously modifying the same engine? Start from scratch, build a new
Create
engine
a
for
whole
that
new
requirement,
concept.
or all new
Mm.
concept. Okay, but you have to reach that stage, I guess.
Yeah, yeah, yeah. Batraji is asking, for AMCA 2, we would require around 120 to 130 kilonewtons thrust engines with variable inlet control. This kind of tech is still in development in advanced countries. Should we co-develop it with the US? This
It
is
will be,
co-development of defense is also part of, I mean, supposedly a part of this deal, right, sir?
it will be. And incidentally, you cannot develop 120 to 130 kilonewtons without these facilities, without variable inlet guidelines, without Condai nozzle. We did not get into those things. You see, when the aircraft moves through the air now, it also starts encountering shockwave problems, right? So you
Mm.
have to have, you have to cater for them. That how do you take flow inside? That is where the next thing, sometimes when we talk, from after jet engines, because they had a limit how much thrust they could produce with all the technologies thrown in. Ultimately, the more the temperature in the combustion chamber, higher the thrust will you get. Okay, that is a standard principle, because the more fuel you are burning to higher level, the greater amount of difference between outlet, that is outer temperature, and internal temperature will dictate your thrust.
Trust.
Okay, now there is a limit to that, limit on two counts. One is how much air can you continue to compress, to what an extent. Okay, and to what an extent you can increase the temperature. So there is a limit which is reached to jet engine, beyond which now, for the same size, I'm saying, that way Boeing 777 engine produces 510 kilonewtons thrust. But you seen the engine? I mean, it is a huge fan.
It's
It
bigger than
is
a fighter aircraft, sir.
a fighter aircraft. That engine itself. But you can't afford to carry the same engine in a fighter aircraft, because beyond a point, thrust to weight ratio which is required for fighters varies. Now these technologies, variable intakes and variable nozzles are part of it. They are already control laws, etc., are incorporated in LCA. Incidentally, it's easier to make an aircraft. These things are not part of the engine now. Incidentally, they become part of the your airframe coordination also. They start interacting with your
Mm.
airframe. That how does it interact with your airframe? It's easier to make an aircraft. We are already making aircraft bodies, and wings and things like that. Already supplying. India is making, TSL is making probably F-16 wings also. Okay, the bodies are being made here, but engine is the issue. So LCA already has some of these features, but of course, what you need for 98 or 95 kilonewtons will be very different. What you need for 120 or
130
130
kilo.
kilonewtons. Thus, we may
Yeah.
even need more. That WS-15, like I said, is talking of 182 kilonewton thrust. Okay, and two Su-30 engines. Individually they produce about 122 kilonewtons of thrust. But when you come to thrust to weight ratio, then even Rafale may fare better, because there are other things which get involved.
So, the attack helicopter segment, are we any close to building good engines like the General Electric T700
Uh,
turboshaft or the Kilmov VK2500?
No, 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 not really, because we have to work there. Even our ALH, it's still being supported by Turbomeca of Safran. Even when we
Safran.
are exporting that individually, the Shakti engine, which is used in ALH also, okay, is somewhat being supported. The complete indigenization has not yet been reached there also. So for attack helicopters, etc., it will take time, but it's a byproduct, I would guess. The main focus is on jet engines now. Once this is comes under control, then probably we will, when we start, making that kind of helicopters now, then that technology will also come, I guess, but
So
not as of now.
there is a let's. I mean, this is a very interesting discussion, and I think the more information that will come out will get even more interesting, because one will be able to actually discuss some more specifics as to what we can look at going forward in the future. I think that's I think everybody's a lot of the questions are asking that, yeah, what can we look at in the future, because that is the main output. But before we bring the show to a close, I have a last few thing, because all these questions that I'm reading, there's this one thing that comes out pretty well, is that when we, let's say we get the TOT here, right, and we are employing Indian labor to do whatever the work is required to be done there, Indian engineers, Indian managers, Indian administrators, everything is set up and stuff like that. A certain amount of know-how does get transferred into the game, into the industry, into the the people who are handling this stuff. How does that impact the setup with regards to the technology development within the country, the indigenous technology development within the country?
It will impact, and I maintain this, that even when this TOT comes, 414, our own effort, should not go down. I mean, one should not now sit back and say, okay, we had to make one, fighter engine, now the technology is coming, now just follow them. Okay, it is like, we are not to get into that cursive writing, that initially, when people nowadays, kids don't do it. When we started to learning writing English, there used to be written, the four lines. I don't know anybody uses that
Yeah, yeah, sir. I used to get beaten up because I
yeah,
could never
okay.
write straight.
So one is that someone gives you an outline
Yeah,
already drawn,
understood.
okay,
Mhm.
and you are happy walking on that,
That
okay,
line.
or that on those dotted lines, you say you're happy that somebody has drawn the sketch for you, and now I can produce a beautiful picture, which I have sketched on that. Or to develop, or you should not stop developing capability. What I feel is that this transfer deal will create an environment. What happens is, Adi, like they say,
Thought
you,
process, yeah,
thought
ideas will
process,
start.
like God is everywhere. You know, God is everywhere. We know it's universal truth. But I don't think so much of God sitting in a pub as I think of him standing in a temple, because
Correct.
it is an environment. Okay, the environment is provided to you, that your thought process, you start thinking on those lines, which you may not do elsewhere. So if this ecosystem comes, people will get interested. Who knows which engineer now, more employment, I guess. There are qualified guys who will start taking up these disciplines now. Today a guy who's thinking of doing his engineering may switch from computer science to mechanical engineering. Who knows? you know that, okay, this is where the future is. Now what happens is, computer science, computer science, computer science everywhere you go, because that was the future. Now when they know that, okay, engines are going to be made here, and this is the future, and this is where the buck lies, the and he's in that environment, he will pick up something. He will bring you some wonders, because you're providing him that environment to grow. So I am very hopeful that this particular deal, it is not a direct give and take. It is going to create a university kind of environment, an educational institution in the country, where people will get involved. They will start thinking on these lines. They will see how things are happening. They will learn how the way things are done. You visit these factories, Rolls Royce factories in the UK, etc. I've been watching those guys doing things. Now I used to go as a liaison visit, but I'm sure an engineer, when he goes there, will pick up a lot of good things. Now if that same setup is transferred here, and he feels interacts with a whole lot of those guys, talking about it, it's a very different scenario. You learn much more. I, for one of my projects, I visited DRDL or GTRE, like I said. You can read 100 books, Adi. you may not pick up that kind of knowledge as you will
Yeah,
pick up by interacting with those 6 to 8 scientists one to one,
absolutely,
because
absolutely.
they are now 100 books compiled into one, okay, into
See, sir,
each one
that's
of
what one can read, and I'm gonna just just as a compliment, I'm saying this. One can read articles about this, but I personally learn so much more in these podcasts because you it's a human factor. जब कोई बात कर रहा होता है कुछ चीज को बड़ा क्लियरली एक्सप्लेन करता है तो आपके दिमाग में बैठ जाती है वो. You don't have to revise it,
yeah,
right? So
oh,
all these
yes.
talks that I do, it gets set into my mind as base knowledge.
Yeah.
I've read
So
about this stuff,
now,
but you don't
yeah,
really understand it.
absolutely.
So you're absolutely right, sir.
And the knowledge can be extracted. You see, one is that I presume that this is what you want to know and I give it as a token. One is that it is probed, so when these guys interact, when this ecosystem gets created, there will be a lot of interaction, there will be a lot of probing, there will be a lot of things happening. People start talking at individual level, they are not
Mhm.
doing so much of government lines, or things. So the देख देख के the environment becomes good. You can do much better in that environment, okay. I mean, you see this singing competition programs, like I occasionally watch because I like music. So what happens is that Indian Idol program, for example, the way these kids can sing in that environment probably cannot do it at home, because they're interacting with so many musicians, they're
Oh,
interacting with so many people. The
ambience and
environment is like that ambience, right? So their talent comes up and improves, which may not have been possible. Same guy, same talent, same everything, but will not come out sitting at home in his village. You need this stimulations, stimulants, what we call. They're all they act like stimulants. So I think this deal which is done will act as a great stimulant for our advancement in this particular thing. I may sound a bit excited about it, but the
नहीं
fact
sir,
is that we have
I think
waited for
all
it
of us
very
are.
long.
Yeah,
And
yeah.
having seen those guys really working, mind you, there is a lot of gap between understanding. When you actually go and meet those scientists who are working, you see the engine lying in front of you, you see how much work has gone in, and the frustration which is there on the faces of people, that why can't we do this, and the problems, all those things probably will get sorted out if this ecosystem comes in without any hitch.
चलो sir, close करते हैं. Let's take a couple of compliments for you. Air Marshal
Oh,
Bedi is definitely a mechanical engineer or aerospace engineer. Batraji says,
thank you.
thanks to both of you for taking up my questions. Air Marshal Ji has explained so beautifully in his simple language to a layman like me. And the third person says, what an informative show. That's a good R. And somebody also wants you to, this your light beard is looking nice.
Thank you so
And
much.
of course,
Your audience is very kind and very informed. I always enjoy interacting with them.
I'd like to welcome Mr. Ravi Rangachari to our community as a YouTube member. Thank you so much, sir. This is a fantastic session. We'll plan the next one as and when I think in the next
Yeah.
week, when we have a little more detail with regards to what is going to happen in the future and how things will actually impact. So we've given us a base knowledge to actually, scan the news for and look around and see if we can also learn something around it. But as I said before, this stuff is a bit technical, but once we understand it in very simple language, one can actually understand, हाँ ठीक है ये है, this is the game, अब आगे चलते हैं. So thank you for doing that, and it's always a
Yeah.
pleasure and honor to have you on the show, sir. Learning experience. Till next time, sir.
Thank you very
Jai Hind.
much. Thank you. Thank you.